Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Determine the molecular formula. Mol. Wt is equal to 86 for an alkane CNH, 2n plus 2. 12n plus 2n plus 2 is equal to 86, 14n is equal to 84, n is equal to 6. So the alkane is a hexane isomer, C6H14. Moving on to the next step. Identify option C. Option C is CH3CH, CH3, CH, CH3, CH3, which is 2,3-dimethylbutane. Megawatt is equal to 6, 12, plus 14, 1, is equal to 72 plus 14 equals 86. Correct molecular weight. Moving on to the next step. Count distinct hydrogen environments in 2,3-dimethylbutane. 2,3-dimethylbutane has the structure CH3, 2CH-CH, CH3, 2. The 4 CH3 groups attached to the 2CH carbons, all 12 hydrogens on these methyl groups are equivalent, by symmetry, type 1 hydrogens. The 2CH hydrogens, one on each central carbon, both are equivalent by symmetry type 2 hydrogens. So there are exactly 2 types of hydrogen environments, giving exactly 2 monobromo derivatives, excluding stereoisomers 1 bromo 2,3 dimethylbutane from CH3 bromination and 2 bromo 2,3 dimethylbutane from CH bromination. And for the final step, check other options. A. 2-methylpentane has 4 distinct H environments, 4 monobromo derivatives. B. 2,2-dimethylbutane, megawatt is equal to 86 has 3 distinct H environments, 3 monobromo derivatives. D. Neopentane, 2,2-dimethylpropane, megawatt is equal to 72, not 86. Eliminated by molecular weight. Conclusion. Only 2,3-dimethylbutane, option C, gives exactly 2 monobromo derivatives and has mol. Wt is equal to 86. Therefore, the correct answer is C. Therefore, the correct answer is option C.